Welcome to this lesson on classifying rational numbers. After this lesson, I will be able to identify rational numbers and classify given numbers as rational, integers, or whole. Keeping in mind that these can be not interchangeable, that's the wrong word. Like an integer can be rational and it can be whole, so they can fit in multiple categories. All right, so first we need to know what a rational number is. A rational number is any number that can be expressed as a ratio of two integers. So basically, it can be written as a simple fraction. Now, there are decimals that repeat and go on forever because they repeat. There is a way to change those into a fraction. We're not going to go over that just yet. I'm just going to ask that you trust that if a decimal repeats, that it is a rational number. So a really easy way to determine if it's rational or not is to look at it as a decimal. So as a decimal, does it terminate or does it repeat? If it does one of those two things, it is a rational number. So here we go. Let's take a look at some of these examples. So 2. 2 can be written as the fraction 2 over 1, and it's also written as 2 decimal 0. So therefore, it is a terminating decimal. So we're going to focus on that. So is it rational? And we can say, yes, it is rational. Oops. Because it terminates. So 0 and 7/10. 0 and 7/10 is a terminating decimal. It can be written as 7 over 10. So therefore, yes, it is rational because it terminates. So 3 and 9/100 repeating. The hard part here is that 9/100 repeating cannot be written as 9 over 100. Okay, it's actually going to be written differently. And without confusing you guys, I just need you to trust that because it repeats, it is a rational number. So yes, because it repeats. The square root of 16. So we actually have to solve this then. So the square root of 16 is equal to 4. So this terminates. So yes, it is a rational number. Square root of 2. So if I take a look at the square root of 2, so I take 2 and I square root it, notice that this number goes on forever and ever and ever and ever, and it doesn't end. Even though my calculator looks like it ends, it doesn't. The only reason it stops is because my calculator doesn't go on forever. There is also no repeating pattern in here. So the square root of 2 is not a rational number. So no, because it does not repeat or terminate. Pi is a number that we know goes on forever. Since pi goes on forever, we know that it is not rational. So no, because it does not repeat or terminate. Now here, even though we don't have the repeating symbol on top, you can see that it goes 1, 2, 1, 2, 1, 2. So therefore, and then these dots here tell us that it continues on in that pattern. So we can say, yes, this is rational because it repeats. All right, so the next thing we're going to do is we're going to take a look at these different sets, and we're going to determine which set contains only rational numbers. Well, let's look at A. Right off the bat, we see pi, and we know that pi is irrational, so we know that A is not a choice. B has 975, which is rational. 7 over 35. Well, 7 over 35 I can write as 1 over 5. And 1 over 5 is equal to 2 over 10, which is equal to 2/10. So I know that it is a terminating decimal, so it is rational. Here, 47 and 201 thousandths terminates, so it's rational. And then the square root of 121. This is where it helps to know my perfect squares. I know 121 is a perfect square, and its square root is 11. So therefore, right now, my best guess is that B is the correct answer. I'm going to go through and double check, though. So the square root of 3, I know is not rational because 3 is not a perfect square. So I know C is out. And then D has square root of 5. I know that that is not rational because 5 is not a perfect square. So my correct answer in this case would be B. If you're ready to try this on your own, go ahead and pause, and then you can check your answers. Otherwise, you can continue with me. So here in A, we know that it doesn't work because of pi. In B, it doesn't work because of the square root of 5. C, we have the square root of 3, which is irrational, so that doesn't work. So here, I just want to double check. If I want to double check and look and do 2 divided by 35 to change it to a decimal, okay, I can look and see that it does repeat. So it goes 5, 7, 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1. So this does repeat. Even though it goes on forever, it does repeat. This one terminates. The square root of 49 is 7. So therefore, my correct answer in this case would be D. All right, on this one, I definitely want you to try it on your own, and when you come back, we're going to check your answer. All right, so B is out because of the square root of 5. C is out because of the square root of 3. And D is out because of pi. So therefore, our correct answer has to be A. All right, again, pause, and then come back and check your answer. All right, so here, your B is out because of pi. C is out because of square root of 61. Okay, 64 is a perfect square, but 61 is not. And here, 31 is not a perfect square, so that is out. So in this case, my correct answer is A. When you're looking at square roots, you have to know your perfect squares. And your perfect squares are going to be, so 1 is a perfect square, 4, 9, 16. These are all your perfect squares. All right, so if we're looking at this number here, we want to know, which one best describes it? Rational, rational, and irrational, neither rational nor irrational, or irrational. Well, because it repeats and goes on forever, the correct answer in this case would be rational. Now, the other question that I have here is, if it's rational, does that automatically mean it's an integer? Well, since this is a decimal, it's not an integer, and it's not a whole number. So in this case, it would only fit in the classification of rational. Oops, sorry about that. And then here, terminating decimals. Are they always, sometimes, or never rational numbers? In this case, they are always rational numbers. All right, the last part that I want to put on here for you is I want to take a look at different numbers. So if I have something like 20 over 4, and I want to know, is this rational or irrational, and so on. So in this case, I have to actually solve it. So 20 goes into 4 5 times. So therefore, this is rational. It is an integer because it doesn't have decimals and it does not have fractions, and it is a whole number because it is not negative. If I were to put a negatives in front, so let's do 35 over 5. So this can be made into -7. So therefore it is rational. It doesn't matter if it's positive or negative. It is rational. It is also an integer, but it is not a whole number because of that negative. Right? So when you're classifying your numbers, you have to know your rules for each one of these, and knowing your definitions will help. So what you're going to do, you are going to answer your guided practice questions, and when you come back to class, we'll go over the answers. And if you have any questions, please be sure to email me or write them down so we can go over them in class.